My name is Muhammad Ameen. I'm a student at Conestoga College. I'll be presenting my PLC Project 2. My student number is 855-4685. Don't zoom into my code that much, right? So what we have here is my simulator. So as you can see, it goes through its normal routine. The bottle fills, goes to the insert cap, the clamp moves, yada, yada, yada. So we got that. So what I'm going to show you right now is, so right now what I got here is my time in cycles. So once the time it takes to complete one cycle. So how I did that was, as long as my green light's on, once it hits the output chute full, that'll be the time for 1 second. So it will reset once it gets to, when it hits that sensor. So now we got a problem here. So what happened is my line shut down. So this is for the signal for maintenance to come. So what I have here is, right here what I have is a fault triggered. So my light's flashing because there's a fault right now, because this has been lowered for more than 10 seconds. So why that's lowered is because the nozzle needs to be cleaned. So I got these signals right here, got these lights right here to signify that. So what I got to do here is once maintenance comes and cleans everything up, it'll press this button to resume, press this button to reset, and this emergency light should clear up. Anyways, now I showed my maintenance. So now what I have here is my ultrasonic sensor that will measure the bottle of the water, or the amount of height of the water in millimeters. So I put that value in right here. Also, I put the number of bottles filled into this alias right here. So other than that, what I got is my delay for this bottle fill. So and also my retract. So this will also delay the retract, as you see right there. Also, I put a delay on for the bottle fill. So as you see, it didn't fill the bottle until a little while after. So now that I gave you a quick run through of my logic, let's show my simulator. Let's show my logic. So right here, what I got is my main routine. Just a bunch of GSRs for my subroutines. So this is what triggers my walking beam and my start cycle to turn off. So I use the counter for this. When it fills, when the counter is done, it will hit 50 bottles. So my counter is in right here. So what I have is a counter. So once it hits 50 bottles, sorry. Yeah. So once it hits 50 bottles, I have that. So once it hits 50 bottles, it should shut off the maintenance. So this is my logic for my maintenance itself. I'll give you a look through for that. I will discuss about my alarm afterwards, Christine. So this is also my conversions for the millivolts to millimeter height. It's just a simple compute function. And these are the timers I use for the cycle timer. And now this is my fault logic. So everything, when something's on for more than 10 seconds, except the E-stop, it should trigger the fault. And when a fault is triggered, it should turn on this flashing light, which is PBB. But for this sake, we don't have it on right now because there's no faults at the moment. And then I have my walking beam delays. The delay for the extend, delay for the retract. And my start cycle, I have one delay, the water fill. So when it will delay the filling of the water. Okay, so now I will discuss about the alarm. So what I did, I can't really do it, but I programmed it anyways. So I programmed the alarm to work. However, you need to program it on HMI to actually create the alarm. So what this does is the number of bottles filled is done. So when it hits 50, it will send in a trigger alarm, a digital alarm. However, I still put tags on them, but I can't really use an alarm because I need to program it on HMI. But however, it's still there. But that's pretty much my project. Oh, except I gotta show you one more thing. So once the e-stop is triggered, it will start the PBB. It will send out the emergency light for fault, and then we'll start back everything up. So that's my PLC project too. Thank you for watching, and I hope you have a good day.